Hey,
Hey, can you hear me all right?
yeah, I can hear you okay.
All right, perfect. How are you doing?
Yeah, not too bad. How are you doing?
I'm good. All right, if you're ready, let's get started. Before we get started with the actual system design mock, I ask a few questions, just to gauge the level that you're targeting and things like that, so that I can probably ask you a question which is relevant to your level, and also judge you on that for that level. So I copied a few questions on the chat on the main text. If you see it, you don't have to type the answers out, but we can just spend 30 seconds on that maybe.
Yeah, no worries. So I don't know how to sum up my experience. I have a non-traditional background. I've been getting paid to write software for like 4 years, and it's mainly been at startups, but I've done all kinds of stuff, definitely a generalist. And the companies I'm targeting are just like bigger, more established tech companies. It'd be great to get a job at a FANG company. Obviously, Google is a dream for everyone, but just bigger and better just in terms of the quality of engineering. You can put me down as 4 years of experience and my level is mid-level.
That sounds good. And then would you say you're closer to 5 or more closer to 4? And I'll tell you why I'm saying that. At Google, for example, the reason why you matched with me is because I have worked at Google in the past 2 years. Google will almost always try to downlevel you, depending on how many years of experience you have. That's not saying that a person with 3 years of experience or 4 years experience can't become an L5, which is essentially their senior. But it is also on the other side, that if you have 3 years of experience and you're aiming for L5, they're going to judge you much harder than they would someone with like 5 years or 6 years of experience. So that's why I'm asking that question. Because if you're closer to 5, I'm going to also see how you stack with not just L4, but also L5.
It's a thin line between L4 and L5, right? Like there are some people with 10 years of experience that get L3 roles at Google and people with 3 years of experience that get L5 at Google. But I think the safer bet is L4 because I already passed my coding screens. So they're waiting for me to schedule my on-site and I'm going to do it when I'm ready. And the thing that I'm mainly getting ready on is the system design.
Cool, let's get started then. So let's switch over to the whiteboard. So for L4, let's do Facebook events. I can generalize the term too, but I think Facebook events is easier to explain. If you don't know what it is, I'll give you a 60-second elevator pitch to kind of explain what you're building. Think of Facebook events as a normal calendar application, but with additional features. So just like you have your Outlook, iOS, Android calendar, or whatever. So you have all the functionality of that. You can schedule instead of a meeting, you're scheduling an event. So you can schedule an event. You can invite other people. They can RSVP with yes, no, or maybe. You have the basic functionality of the calendar, like notifications, reminders, where a notification is more like, hey, XYZ invited you to the 4th of July barbecue party. So you can click on it and go to the app and then RSVP with yes, no, or maybe. Maybe the second part of it is reminders, which is like this interview. If this was an event on Facebook, you would get a reminder an hour before saying, hey, your interview with interview.io mock interview starts in 1 hour. That's the part that comes from a basic calendar. Now comes the additional Facebook features. The first one would be each Facebook event gets its own Facebook page where all the people who are part of that event invited to it, RSVP, yes, whatever, can interact with each other. So they can create posts, they can post pictures, basically start threads and talk to each other. The second part would be, which is the last one, would be an event will have much more metadata than a normal calendar event. So you have the name, location, description. But for a Facebook event, you can also attach, because you're creating a Facebook page, you can attach pictures as well, which kind of become your background picture or your title picture for the event itself.
So there are two basically subsystems of Facebook events, the calendar and then the Facebook features.
Yeah, you can say that. The Facebook features are essentially built on top of the calendar. And then there's one more, which if we have time, we can do. It's like an extended set, so events can be public or private. So the additional feature would be able to search public events around you. For private events, they should not obviously be accessible by anybody, except the people who've been invited to it.
Public events would be searchable, and then you can find them within a certain mile radius or something.
That's again, if we get to that, it's more of an extended scope. We'll discuss it then, because theoretically I want to go to Boston this weekend and I want to see what's happening in Boston.
Okay. So yeah, so just focus on the calendar and the Facebook thing. So you said for the calendar, there were two parts of it. The reminder was the second part. What was the first part that you mentioned?
You're talking about notification and reminders.
Yeah, I think that's what it was. So this is basically the same thing functionally for the user. Like what the user would see would basically be just a Facebook branded Google Calendar, basically.
You have a Facebook app, you go on it, and then one of the sub-tabs, because Facebook has so much other stuff, right? One of the tabs would be called Events, where you can click on it, and it will show you a list of all of the events you have RSVP'd yes or no to. When someone invites you to a new event, you will basically get an iOS notification, which you will click on, and then it will open the event page where you can then RSVP your decision. And if you say no, it should not show up in your events list essentially, right? Because you already declined that event.
All right. Yeah, calendars are the tricky parts. A lot of technical challenges that come with calendars. I've never built one personally, but I've been around it. Just trying to look at this and see what's going on.
Don't worry about building the calendar itself because you're not expected to build like a calendar view like you would see one today if you open the calendar app on your iPhone. Essentially, the reason why I say calendar is because it's the most closest thing to explain what you're doing. But essentially, you're not expected to create like a calendar view. Essentially, what you're going to create is maybe an API called getEvents, where you will extract in chronological order all the events I am going to in the future that I've said yes. Or like past events that have been so that I can go to their pages and like maybe, I don't know, share pictures or whatever I want to do.
All right. So obviously, like this is probably pretty high scale because Facebook has a lot of users. So do we imagine that we need to worry about exactly how many people are going to be using it, or should we just say it's going to be a lot?
That's your choice. I can give you a starting point. Facebook published that there are 4 billion monthly active users on Facebook. We can set a number. Let's say 20% of them interact with Facebook events in one way or the other. So you're looking at what, 800 million monthly active users?
Okay. Obviously, they're all over the world. So different countries. Okay. Traffic is predictable? Probably not. Right. This is probably going to be like if Harry Styles is in Boston tomorrow, that's going to be different for how many people are going to use it. So it's probably availability seems like the most important thing here. Like if I'm trying to go to one of these events, I'm not going to get mad if the database, which I can't see, doesn't have the same data as the data on my app, on my device. I'm going to get mad if I try to access it and it's not available. So it seems like availability is like the most important thing for user experience here. Most important thing for user experience. Okay. Number of simultaneous events. Probably a lot too, right? Like concurrency. This is the number of daily active users, right?
Monthly active users.
Number of monthly active users. Location. Countries across the globe. So then this presents a tricky part because we don't want a user in Japan to have to be routed to servers in the US because that's unsecure or less secure. So I'm just looking for the things that would just be like complicated, especially complicated. Obviously, the scale is a lot. There's security considerations to make because the users are spread out. Traffic is not really predictable. It's actually highly unpredictable. Number of simultaneous events, probably a whole lot. Like we could say probably in the hundreds of.
Yeah, that's easily possible. I mean, I could put it at thousands because if you look at all the private events, things like, I don't know, 4th of July or whatever, you could have a lot of events going across the US in parallel, right? Or New Year's Eve, for example.
Right. And all year long. Okay. So what else should we be looking for here? So if we're thinking about the system, so the system is obviously something that's big.
It is something that we want available all the time.
It is something that we want to have some kind of fault tolerance in place or some kind of way to balance the load when the traffic gets really high, highly unpredictable. So we need a way to balance the load of traffic.
Number of simultaneous events all year long in the thousands.
I'm going to skip this for now because concurrency is super hard to understand and just focus on what the system would look like if it were only like a few users. We can just designate them user A and user B. So what else is important here? So we've got to be thinking about the system. We've got to be thinking about the users. We've got to be thinking about the traffic. So the users and the traffic feels pretty good. The system, in terms of the data that we're going to be storing in our database, I'm trying to figure out if it's going to be something that we want to structure or leave unstructured. I think that my gut would be unstructured because writes will be faster. But if we do unstructured, then it's going to be slower for reads. And imagine the people that are using these, like something like Twitter, like if you look at all the users on Twitter, like what ratio of them are actually like writing?
It's obviously read heavy. I feel like there are people who write a lot, but then at the same time, there are a lot of people who never write. Like, I don't even think I've tweeted once in the past 4 or 5 years, but I go on Twitter every day.
Right. But this calendar probably feels different. Like I use my calendar every day and I'm always writing in it. And I think that I would say that the number of writes, the number of write to read ratio is higher on a calendar than something like Twitter.
Yes, I agree with that. So yeah, because you also have a lot of other data points, right? You create one event and you invite 500 people to it. All those 500 people going and RSVPing yes, no, or whatever is actually modifying your data.
Right. And that's getting to the notifications and reminders thing there. So that's important. You're storing the data. So unstructured and faster for writes. Okay, thinking about these features here. Features like notifications, reminders, and then own page, interactable page, more metadata. So, okay, should take these one by one. And there's only 4 that we're focusing on right now. Okay, notifications, reminders. Each event gets own FB page. This is interactable. Okay, number 4. Event page will have more metadata because people post stuff. All right, I'm going to ignore videos just because videos are way more complicated than pictures for now. So I'll say they will post pictures for now. Okay, so the features and notifications. So just sending, making sure that each user has a unique user ID, and when they are signing up for an event or they are rejecting an event, that they can be notified from the service. So I would say a notification service. I can leave that as a black box for now, but it wouldn't be too complicated just to know which user it's talking to. I mean, users will be authenticated by the time they're trying to get notified by something. The reminders would be similar. This is where it gets really kind of complicated down, a little bit more complicated down here is each event gets its own Facebook page, which is interactable. So if it gets its own Facebook page, that's a public page that other people or the creator, each event gets its own Facebook page. So we would need to like shard or like break down, at least from the perspective of what we're displaying to the user. And those pages wouldn't necessarily be around forever, like that Harry Styles concert this weekend or whatever in Boston. It's not going to be there next weekend. This reminds me of another problem. I'm trying to remember what problem this reminds me of. Not that like that matters, but I'm trying to think of a way to just conceptualize like what we're talking about. And it's still not sticking. So it kind of reminds me of something like Ticketmaster.
Why do you think that? Because Ticketmaster is completely different. They're going to get an influx of traffic when the tickets are released to buy them. You're not going to have that influx of traffic in the sense that everybody is not going to show up on your Facebook events page on Saturday, because there's a Harry Styles concert on Saturday evening. Yes, you're going to have to send a lot of reminders on Saturday. That part I agree, but you're not going to get an influx of traffic. It's going to be system-generated traffic, right? Because your backend will trigger those reminders. Nobody's going to come in like manually trigger something. But Ticketmaster is the other way around.
So a lot of people aren't going on each Facebook page then? That's what I'm hearing you say?
They're not at the same time. They could show up later for whatever reason. Think about it this way. Do you go and check your calendar every Saturday to see what concert you have to go in the evening? Probably not, right? You get a reminder and then you look at it.
I guess no one's going to be trying to change the same resource at the same time.
Correct. It depends on how you design your resources.
Okay. For this notification service, reminder service, each event gets its own Facebook page. Event pages will be able to post pictures. I'm just going to start thinking out loud a little bit about how to actually make this. Don't hold me to any of this. I'm just thinking out loud. Obviously, it's going to be good to have some kind of database, at least one just to start with. Let's just say this is no SQL. Again, going off of what we said earlier, if we wanted faster reads, we don't. But if we wanted faster reads, we could go with SQL, but we want faster writes. Also, if we end up getting, never mind, I guess I can worry about that later. What else? If there's a user A and user B over here, just calling them that because we don't know where they are, we will need to break something down. I don't know if it's going to be the database or the data the user sends us or something else. But whatever we need to serve up to them, we do need to make sure that they get all the stuff. I'll just say user one. So there could be some kind of server here that we have. Maybe there will be separate databases. These would be replicated databases. Okay, so if we just have this, if we had something to balance the load, that would definitely be helpful. We want things to be easily accessed. So I'm going to cross this out for now. So this is something that can just balance the load. And then if we had this server, once users are authenticated, so user one would go on the web page, log in, they'd be authenticated, they'd come into here. Okay, so what we're going to do is we're going to make sure that they get all these services. So I don't just want to call it service one and service two and service three, but ostensibly, if we had, for now, this would be a black box. Something like notifications would just be, okay, the user is authenticated. They are being notified 10 minutes before the next event. So that would be like a notification service. This one would be for reminders. How is a notification different than a reminder? Wouldn't they both be notifications?
Yes, but I am hoping for you to tell me how a notification is different than a reminder. The end goal is the same. Yeah, you'll get an app, you'll get a Facebook app notification on your phone. But how are they different?
Oh yeah, one's coming from us and one's coming from them, right?
Yes, and?
Well, notification versus a reminder. Notifications are happening all the time and reminders are time-based. They're time-bound based on the upcoming events.
Yeah, but that doesn't matter, right? Because if you're a user, you're going to be getting notifications. Even reminders will happen all the time because your events will happen all the time. Think on the times of like consistency and timeliness, etc. Think on those lines.
So thinking along the lines of consistency, we want to make sure that this communicates with the database and this communicates with the database, but that it doesn't. We can go two ways here, but only one way to the database. So yeah, it's to make sure that the database is consistent with the notification and reminder service. That's what I would be thinking. We can't have it all, but I mean, yeah, I think that's important. Timeliness.
Oh no, I'm asking you to differentiate them both on the basis of timeliness.
Oh yeah, well, this one's going to be more often.
I was trying to give you a hint, but let's get into it, right? A reminder for, an event that starts at 5 p.m. And you have it set to be delivered 1 hour before. You expect it to show up at 4. It shouldn't show up at 4.01. It shouldn't show up at 3.59. It should show up exactly at 4.00. Whereas I create an event and I invite you, you can get a notification 5 minutes later, and you wouldn't even know that it was 5 minutes late because you don't know you've been invited to an event until that notification shows up.
So are we talking about something like a timestamp or like a scheduled job or something?
No, I'm basically differentiating notifications and reminders for you. One has to be strongly consistent and reliable and timely. The other one can be eventually consistent, because until that notification shows up, you don't even know that some event was triggered where you were invited to an event. Or, for example, like if I change the time from 5 p.m. to 6 p.m., 5 days before the event, you wouldn't know that something has happened until you get that notification. So, it's not a bad customer experience for the notification to show up 500 milliseconds or 500 seconds after the actual underlying trigger happened. Whereas for notifications, reminders, even waiting 60 seconds is a bad customer experience because you expect your alarm or your reminder to work on the time you set it to.
So I think we're talking about just the way that the contract between the machines, the way it's set up. But this helps now to make the reminders real-time updates, and they're written into the database, whereas we're batch updating the database for anything that's a regular notification.
So why does notification have to be in batches?
Because it's not as important to happen instantly like the reminders.
Okay, I get that part, but still, why does it have to be in batches? So it can be backlogged. I agree with that, but I don't agree with the batching part because then you're increasing the latency intentionally by saying, hey, even if the server is literally empty and nobody's using it, I'm still going to hold you up for 5 minutes because I'm batching every 5 minutes.
So backlog it? I think backlog sounds better. It sounds better because the latency with the batch job would not be worth it, especially the scale that we're working at. So, okay. And the API would be pretty simple here. It would just be for somebody who is trying to just look and see what events that they've signed up for so they know what they're going to be reminded of. It would just be from the user, like a get event. And if it's something where they wanted to go back in time and see all the old events they'd ever been to, then it could just be something like a get, past events or something like that. Each event gets its own page and it would be an interactable page. Okay. So when the server has user 2 authenticated and are authorized to make an event or interact with an event, it would then be able to go here to an event page. And then once they're on the event page, there probably would be things, again, there wouldn't be 1 million people right now and then 0 people 10 seconds from now, but there would be people coming all the time. And just to decrease the load on our database, we could have a cache for the obvious things that are going to be on those event pages, like picture of Harry Styles fans, or maybe like if a user logs in from Korea, there's a picture of Harry Styles eating Korean food, or if they're logged in America, there's a picture of Harry Styles dancing like Britney Spears or something. So if we have our event service, it seems like it would be smarter to have that event service utilize a cache. So then the cache could lower the load from the event page that would be pulled up all the time. And then it could go to the database if it needs to.
But we don't even necessarily need to have.
I'll just make it an option. So we can have, it can make some kind of decision where it can be a simple decision tree, whether it should just be written into the database, but this is more unlikely. The cache is more likely. I think the things that would be worth talking about here are just to try to make it as simple as possible. I'm just kind of thinking about this like event pages, almost like Pastebin, like again, no videos, not TikTok, not anything like that, but just a page where somebody can post a picture and do like simple stuff on that page. And again, because if I'm a user on this page, the last thing I want is for it to be unavailable because then I think the show is not going to happen. So if we have a cache to serve up the stuff that users are going to want all the time, that would be a good user experience for them. And then when we decide it's important, which we could figure out at a later time, then we could actually write that data in the database to make sure it's consistent. So yeah, I think we can relax the consistency constraint, especially over here with the event pages, because the stuff that's in the databases is going to be less important than users getting what they need quickly. Trying to think about what else is going to be good here. So events can be public or private. You can look at what public events are happening. So yeah, so this is important. So if there's two different kinds of events, like it's kind of like interviewing.io, like having used this platform just today, and if we were writing code, we're not. But if we were, we wouldn't want it so that there was no layer of separation between the code interviewing.io has on their website and the code that we write on this page. In that same vein, we would want to a degree of separation, whether an event is public or private. I've never really thought about that before, about if I'm trying to make events that are either public or private. I think what we would be talking about is authorizations. No, like this is a security feature.
Yes and no. So let's say it's a public event. Sorry, it's a private event, right? You wouldn't have any way to access that private event. Basically, unless you were invited to it, because your list of events would not show you that event. Theoretically, I could send you the link to the event page and you can try and open it, but we can make it out of scope that Facebook security and authentication will take care of it. It already exists. You don't have to build that, like you can't access a link that you don't have permissions to. But if, on the other hand, it's a public event, you will be able to access it because it's public. You don't have to design that part.
Well, then can we just say it's a black box service that's going to take care of that for us? Okay. Well, it's actually not even necessary. We can only make one. So this is, if necessary, this would be the private ones. The public ones are already here. That's the E, which is the regular event. That's the baseline. Private ones would be different ones. And there'd be a black box. We can hand wave it for now. But just say that somebody would have to use some authorization as a part of making sure people only get what they should have access to. And they could do some kind of salting or hashing or some kind of security measure to make sure that that's done. They could figure that out based on the other needs of the system, because this is all theoretical. But yeah, okay, yeah. So overall, this is a very primitive design. But if you have questions or things you want to deep dive into, I'd be happy to do that.
Oh yeah, I mean a bunch of stuff. I want to understand how would your reminders, you said real time, but I definitely want to know end to end. How do you expect them to be real time? And by real time, my assumption is you mean on time, not real time.
Yeah, definitely. So that's a good question. I don't know off the top of my head. I've never worked on something like that before. We just want to make sure it's low latency so that there's zero delay.
I mean, essentially all I care about is if my config is set to remind me 1 hour before the event starts, a 2 p.m. event, I should be reminded at 1 p.m. my time zone. You need to fill the black box of how you make that happen.
Right. Is this like more of a first and last out kind of thing where we're just looking for the method in which the machine decides what order to take stuff? Is that what you're saying?
I mean, that could be part of your design. I am asking you on a scale of 800 million users per month. How do you build a system that, essentially you have some data stored in a database, right? Again, we'll talk about how you have stored it, what you're storing, but you have a list of all the events that are going to happen in the future in a database. How do you go about notifying me? Who is one of the invitees in one of those events that, hey, your event starts in 1 hour when it is 1 hour away from starting?
That should just be a scheduled job, no?
Okay, so let me ask you a few questions then. Let's say it is a scheduled job. What time would that schedule? So again, let's take this example, right? 2 p.m. is my event. You're supposed to notify me at 1 p.m. What would your scheduled job look like? What time will it start? What will it do?
It would probably start sooner than it has to, so it's not late. And it would probably look through all of the people that have signed up on that event and RSVP'd, and then send each of them a ping.
Okay, so let's put it into numbers, right? So you're saying maybe start a job 5 minutes before 1 p.m.
Again, like 800 million a month. I don't know if you want me to do the math, but like 800 million a month, that's like almost 1 million a day, less than, or sorry, a little bit more than, it's a little bit more than 10 million a day. So yeah, these are thousands or hundreds of, anywhere from tens of thousands to hundreds of thousands of users that it would have to look through.
Let me throw another. You're assuming that every customer only uses your events once a month, which is not true, right? I could be invited to 5 different events in a month.
Right. Yeah, there would need to be a user ID so that we're not a user ID, but an event ID and a user ID.
Okay.
But yeah, if the machine could check the user ID and then check the event ID, if they would know which user to send which event ID ping to. But yeah, in terms of scale, yeah, I'm just going to call it roughly 10 million a month, but that's, sorry, a day, but that's assuming they only do one a day.
That's fine. No, you're fine with 10 million a day. I'm fine with that.
I'm honestly not sure how long that job would take. I really don't know how long that job would take of looking at all the user IDs that are signed up for event A and then sending all of them an event reminder 1 hour before. If the event is at 1 and we want to remind them at 12, certainly somewhere between, like, I don't know, the level of, system people that Facebook has, the level of people that are working on this other stuff besides this, I would imagine that.
Yeah, but let's talk theoretically, right? Let's talk theoretically. The reason why I was asking you for the number is for you to think about it from a bigger picture point of view. So what I mean by that is on 4th of July evening, when you're going to have probably 10 million events happening in concurrency versus a random Tuesday afternoon in the middle of February in Alaska, the amount of events happening are going to be drastically different. So you cannot rely on a batch job to do your job because even if you put it at X minutes, that X is arbitrary for this conversation, either based on the number, your data that you have. Either it will run too fast and notify me 1 hour 15 minutes before, which is bad customer experience, or it will run too late and notify me 30 minutes before, which is also bad customer experience.
Yeah, but it's even worse to get notified late, probably.
Yeah. I mean, in this case, anything which is not timely is bad customer experience.
Right.
Because there's an expectation set out of the system you're building, and the expectation is for it to show up on time. So that being said, the reason why I was using that as an example is to show you that the batch job will not be real time, like timely, because you cannot classify the parameters of the work the batch job has to do.
Similarly, like, unless there's a threshold.
Okay, let's talk about that. What are you planning to threshold?
We could have something where if it's over a certain amount of, if an event has over a certain amount of signups, it has a different job than if it has under a certain amount of signups. We have multiple machines, we could be shard the database into multiple machines. If it's over 10 times the normal amount.
Yeah, but then Facebook is also ever growing. So how do you decide the normal amount?
That could be relative. The number could be relative. Last 90-day average 10 times more than the last 90 days average.
Yeah, okay, I get that part. But to even find out if your event has less than or more than 500 people, you will have to query your events database. Now query that events database for that specific event. You need to have a second batch job. Start that querying of the number of users in that event. Otherwise, how would you even know that I'm supposed to send out notifications for event X at 1 p.m. without actually querying your list of billions of events that you've stored?
Yeah, if we want to do it in one call, we could use something like GraphQL. Like most of the time, people have no idea what Facebook uses. But if they're using REST, it's going to be different than if they're using something like RPC or GraphQL. A lot of this could be avoided if we just had the GraphQL happen, because this is good for customer-facing apps, which this definitely is. Because we're going to be doing a lot of stuff user-facing fast. Also, it lets front-end developers make changes without requiring any work from back-end engineers. So that would just help some of the stuff that we're talking about here, but probably not this exact thing. If we wanted to have the notification reminder service be aware of how many people have signed up, and then I'm trying to figure out what we're trying to figure out right now.
I've used GraphQL in the past, and I see where you're going with it. I get it. You can join two things into one with GraphQL. And I have nothing against that. But what you're not understanding right now is the part that I'm trying to basically explain to you, is that with a batch job, you will not be able to deliver it timely. And there are a couple of other reasons for that too.
So we either shard the job or we shard the database.
Okay,
We have to break it down to a smaller, right?
Let's skip that component right now and come to the second part, which is, let's say somehow using a black box system, you're able to find out at a correct time that, hey, we need to notify user X for an event. Then you fire up a notification using your backend service. What about network latency? There's going to be some kind of network latency from your server to my phone. And again, you cannot in any way know what that network latency looks like. I could have Wi-Fi and you can deliver it to me right away. I could be in the middle of mountains and desert and I have like a 2G.
Then a cache would reduce latency, but I don't know. It could reduce latency of an expensive computer job or a network call or a database query or something. So that sounds pretty good here.
Okay.
Probably a cache in between the calendar service and the database.
No, but again, so that's the part where you were talking about a different section. I'm talking about network latency between Facebook backend servers and my cell phone.
Oh, you want it between the user and our server?
Yeah, I'm not worried about how you do it on the back end of the server. I'm sure that's solvable with caches and stuff. I'm talking about the exit point of Facebook servers and my cell phone. How do you deal with that network latency?
So we don't have to store it again. We would build it around this first line of servers here. The first S. I don't know the specific brand, but we want to say that there's a cache that could serve up data that users could get quickly. You got to remember, like 80% of queries should be served by 80% of queries should be served by like 20% of the popular data, which is stored.
Yeah, I get that part. So I agree with that. I am not denying that in any way. What you did by installing that cache at S, I'm going to say at S because you technically do not own the line between user 1 and S. S is where Facebook starts. Anything outside of S is like outside the scope of Facebook. It's the internet. Let's say you install a cache at S. All that did was it reduced your network latency inside Facebook. So now you don't have to interact with N. You don't have to interact with R. You don't have to interact with your SQL. All of that got reduced to, theoretically speaking, 0. But that still did not in any way change the time it would take from S to user 1.
Okay, so the cache should be between the user and the first server then.
How would you do that? Like, how can you build a cache on the internet, which is like you don't own any of that?
Again, this is what I originally said. It should be around the calendar service. So the server, which is S, is going to be pinged by user 1. Then the server will say, okay, do I need to send this all the way to the database or can I get this done in the cache?
Okay.
And the cache will say, yes, get this all the way to the database.
I have a question.
Yeah.
No, you lost me there. You said your user 1 would ping S, but in terms of reminders, your user 1 is not going to ping S. Why would the user 1 initiate a ping to S for a reminder? Reminders are server initiated, not user initiated.
So this is about notifications. You're right. This is about 1 hour reminder notifications. So I'm not looking at the design because it's not exactly how it needs to look. But when a user has been notified, that is a good thing. When they're notified on time, that is a great thing. So we're going to put a cache around the scheduling service so that when it is 10 times more than our usual traffic, the cache will have the 1 hour reminder job that then they send directly back to the server as opposed to a whole bunch of latency by that job going all the way to the database. So that's the thing. The baseline, if it's under 10 times the normal amount of traffic in the last 90 days, we can send that through the scheduler as usual.
You're trying to fix network side latency. Sorry, Facebook internal latency. And I'm not asking you to fix that. I'm saying that's not a concern.
We can't put a cache between a user and the server that I know of. Maybe there is a way to do it, but I've never done it before.
No, it's not. I'm agreeing with you, which means that that's not the way to solve this. There has to be something else that can be done.
Okay, it has nothing to do with the event.
Let me give you a hint. Let me give you another hint. When you're flying today, if you have an event on your calendar with Google or Android or iOS, whatever, you still get your calendar notifications on your phone, even though you're not even connected to the internet.
Oh, we can have it on the device. You can have the device store it.
Yeah. Your calendar works even if you're not connected to the internet because your device is synced to the calendar.
Oh yeah, the cache. Yeah. Okay, it got the data from the cloud. So I don't know how that would work. I can try to limp my way through that.
We're kind of also at time. So I'll stop you here. I was just trying. That's why I was still asking you like 20 different times. You're trying to solve the wrong thing. Think about between S and the user. And you kind of got the idea that there should be a cache, but you couldn't figure out where the cache needs to be. And that's why I was telling you you own S. You have an app on the user device, but you don't own the link between them. The idea was to kind of somehow, without telling you, tell you to put it on the user's device, which you can because you have an app running there. You have storage space. Let's come to the feedback part, which is essentially what you paid for. So on a high level, which is what I would tell a recruiter if this was you and I interviewing at Google, I would definitely say lean higher for L4. I would not be this is definitely not a strong hire because I had to give you a lot of hints and guide you through. It would be a lean hire in the sense that if your other interviews are bad, I'm not going to try and defend you and say we should still hire them. But if all of your other interviews go really well, I would not say no. That's it's like a very bottom-end hire. And the reason for that is 3 things. And now we're going to the detailed part. So I think you started off really well with writing down everything. You got the right idea. However, basically I know 0 about your data modeling at this point of time. The math I'm not that worried about because it's Facebook scale. So we don't need to do that math. However, when it comes to data modeling, how would you store this data? How would you divide event list, invitee list, user list, all of that stuff? Obviously, it's not going to be in a single NoSQL database, right? How do you divide them? How do you connect them? I have none of that information.
You want a more detailed look at how the data would be structured in the database?
Yes, because you're interviewing for a mid-level to engineer, right? Not an early on, but a mid-level engineer. The basic goal is you're able to do your work and draw a design for the system with some guidance from seniors on the team. They shouldn't have to solve the problem for you. They should be able to just tell you what the problem is and guide you towards where you get a solution. And then you do it. If the data modeling itself is a blank for me, then I have to do it myself. So I expected you to do that part. For the system design, similarly, I feel like there were a bunch of times when I had to stop you and say, you're thinking about the wrong thing, or you're going in the wrong direction. This is not even a concern right now and guide you to the right thing. At mid-level, I don't expect you to come up with client-side caching and all that yourself without any guidance, which is what happened here. I guided you and eventually figured it out. But at the same time, I also do expect you to take the hints and take the guidance I'm giving you, rather than keep going on in circles on the same thing that I've already told you not. I told you at least maybe 3 times not to worry about network side, like server-side latency. But even then, in the back and forth, your responses were all trying to solve Facebook server-side latency, which was not even a concern here. So definitely work on that. Take the hint and work on it. Because if you don't take the hint, that's technically at Google specifically. I can tell you it works against you in terms of like Googliness that somebody gave you a hint, and you just blatantly ignored it and continued with your thing. A lot of companies don't use it against you, but Google does for sure. I can tell you that from experience. The last thing that I would leave you with would also be, again, I know it's a mock interview and it's like the heat of things, but definitely be cognizant about your language. Because again, this is a very hit or miss thing. Some interviewers don't care. Like, I wouldn't ding you for it. But I personally also know interviewers where if you basically, I don't know, use the F word, do this and that, that's like an immediate, yeah, we don't want to work with this guy. Because the idea is that you're also judging this person to be that if this was your peer, would you like to work with them or not? And I don't want to work with someone who gets frustrated in a system design when questioned and goes like, I don't know what to do. So in a mock, it doesn't matter much. But since you paid for a Google mock, I'm telling you from a Google point of view. With some interviewers, it could be an immediate strong no hire. And if you get a single strong no hire on your record, you get a single strong no hire on the record with someone who has more than 5 years of experience at Google, you're blacklisted for I think 5 years or something.
Okay, so don't bomb any of the rounds. I just want to know about the power of an individual interviewer at Google. Like, let's say that you said earlier, if someone's a strong hire, then you can like basically fight for them. How does that work?
So the way it works is that let's say that you did 5 rounds, right? And 3 people, 4 of them are saying hire and strong hire, and 1 is like strong no hire. I can fight them and say, no, I think that's an outlier. And we need to redo this interview. And then the recruiter will reach out to you and say, hey, the committee decided to redo 1 round. So when are you available to redo this? On the same thing, if 4 people are saying no, like 4 people are on the fence, and then 1 person is saying hire, that 1 person, depending on how senior they are, can technically fight and say, no, I think I have strong signals for this person. What then happens is you still do another round, but you do another round with another senior, who will then decide whether to agree with someone who's more senior than the person who's trying to fight for you, whether to agree with that kind of thing. Or whether to agree with the other 3 who were on the fence and hence not hire that person. Because if you get all on the fence, that also leads to a no hire, because we don't want to hire someone who's everybody's on the fence about.
So if you get 1 person to give you a strong hire, then they give you another chance. And that is another round, whatever. It's not like it's like a strong hire person could fight so hard that you just get the offer. That's not how it works.
And then also I must call out every peer does things differently. This is my public service announcement. They could be like YouTube, for example. YouTube could do things very differently than ads does, for example. So take it with a grain of salt is what I'm saying.
Yeah, this is cool, man. I'm probably going to stop by for more mocks, but this was a good first mock on the platform. Thank you.